In the last video, I've talked about how when you have a current in a uniform field, the force acting on the wire with the current is given by this formula. F is equal to BIL, magnetic field strength times the current times the length. Now let's try out this formula for some values just to see how it works. Now suppose that the magnetic field strength is, I'll just write it out here, is equal to, let's say, 0.1 Tesla, 0.1 T. Now T is the unit for magnetic field strength, Tesla. I shall talk a bit more about how the Tesla is defined later on or in a later video. So for now, just note that T, Tesla, is the unit for magnetic field strength. Right, the current, let's say there is a current I of say 0.1 ampere as well, not as well, but 0.1 as well, so 0.1 ampere. And suppose that the length of this piece of iron rod, suppose that the length is 30 centimeters. Okay, so let's say 0.3 meter. So suppose that these are the values that we have in this setup. So if I now want to calculate the force acting on the iron rod, I will substitute these values into the formula. 0.1 for B, 0.1 for I, 0.3 for the length. Okay, so the answer is 3. Let's see. 1, 2, 3 decimal places, so 0.003 Newton is the unit for force. So this is just a quick example of how we might use this formula. And I also explain later how you could actually use this formula as a way of measuring magnetic field strength, for example, because with this formula, it actually gives us a way of measuring the magnetic field strength just by measuring the force. Because we know how to measure force, we can use a spring balance, just as a simple example, or that there can be other ways like weighing machine and so on that we could use to measure a force. So if you can measure the force, the currents, and the length, then we can use this formula to calculate the magnetic field.